Alrighty, guys, we're going to continue on with our lessons in Unit 6 quadrilaterals, and today we're going to talk about the properties of parallelograms. Okay, um, now I've included, there's 4 theorems normally that we talk about, but I'm going to skip the last one because it's not, to me, it's not that super important. We're going to focus on the first 3 and use those pretty regularly. Okay, so let's go back, let's start up here at the top. Now I want to remind us of what a parallelogram is. So yesterday we learned that it is a quadrilateral with 2 pairs of opposite parallel sides. Okay, that's just a definition. I want us to remind us of what that is because we're talking about parallelograms all day today. Okay, so there's 3 big theorems we're going to talk about, and if we had time, what I would do is I would have give you an actual parallelogram with measurements, and I would have you kind of self-discover these for you. But for time's sake, I'm just going to give them to you so that we can just use them. Okay. So the first big theorem, Theorem 6.1, says that in a parallelogram, the opposite sides are congruent. Okay. So in our picture over here, AB and DC are opposite. So we're going to say they're congruent. And we can mark that ourselves. And then the other opposite side, AD, is congruent to BC. So we can mark that with 2 ticks, okay? Sorry, thought I had an eraser marker on the paper. So that's the first theorem. Opposite sides are congruent, okay? Second theorem, the opposite angles are also congruent. So if we're talking about angle A, who's opposite that angle would be angle C. So we would say angle A is congruent to angle C. And angle B is congruent to angle D. So they're opposite. Now if we want to label that on our picture, we're going to use these little arches. So we're going to put 1 arch on A and C. That tells us that those 2 are congruent. And then we'll put 2 on the other pair of angles. And you got to use an extra arch because if you just put 1, that would technically say that all the 4 angles are congruent, and we would then have a rectangle. But that's not what we want. We want a parallelogram. So you got to have 2 pairs. Now this extra info, we're going to talk about the angles on the same side. So we're going to say our same side angles are supplementary. That's technically not a theorem per se, but it's just an observation that happens, and it's kind of important to know because I'm going to have you need to use that at some point. So like for one example, we could say that angle A plus angle D equals 180 because remember supplementary means they add up to 180 degrees. So we'll say angle A plus angle D equals 180 because A and D are on the same side. Another example, we could say angle B plus angle C equals 180. All right. Third one is concerning the diagonals. So the diagonals we say the diagonals bisect each other. Now, if you're unfamiliar with that word, bisect kind of means to cut in half. So when diagonal BD crosses with AC, they meet here at O, and it cuts each one in half. So we're going to say the distance from A to O is the same distance as C to O. Okay? That's your clue that the diagonal AC has been bisected, cut in half. Okay? We also say that BO is congruent to DO. So BO, we'll put 2 dashes, DO, put 2 dashes, okay? Now another thing I want to add here, so let's kind of section this off. We know that AO plus CO gives us the whole length AC, right? We kind of know that. That's pretty easy to see. But what else I want you to see, let's write that out. AO plus CO equals AC, right? Well, we just said that AO and CO are the same thing. So we can kind of say this as 2 times AO equals AC. Or we could say 2 times CO is also AC. Okay, you could also do it accordingly for the BO and DO. I'm just not doing it right now. I wanted to add this here because you're going to have problems where they'll give you a piece of the diagonal and they'll ask you for the whole diagonal, right? And so what you would do is you'd have to double this little piece in order to get the whole length. Okay? Now we're going to skip this one just because I just feel like it's not that important. So we're going to skip it. Okay, that's all the theorems we have. So this is our source of knowledge for using these things, okay? To solve these problems. Let's look at some of these problems. So I told you it's a parallelogram. That's important. You have to know it's a parallelogram. We're going to find these measures. And all we know is 2 sides and an angle. That's all you need to figure out the rest of this stuff, okay? So AD, that is right here. Do we know the side across from it? Because we know that opposite sides are congruent by theorem 6.1. So we look across. Hey, we know it, so we're going to say it's 8. That's all you do. Okay, this is like the base level. Okay. DC, that is this bottom side. So I'm going to look across and hopefully I have it, and I do. It's supposed to be the same thing, so we're going to say it's 15. All right, the measure of angle A. So I want this angle measure right here. We'll put me a dot there. The only angle measure I know is angle D here at 68. And we said on the front that the angles on the same side of the parallelogram are supplementary. So we know that the measure of angle A plus 68 is supposed to give us 180. Well, to find the measure of angle A, we could just subtract the 68. So the measure of, well, right over here. So to get this, we're going to do 180, subtract 68, and that should give us what we need. If you do that, you should end up at 112 degrees. Okay? Angle B. Angle B is right here. It is across from the 68 degrees, so I know that from theorem 6.2, that's supposed to be the same. Angle C is across from angle A. I've already found it, and it's supposed to be the same thing, so I'm going to say it's also 112 degrees. Okay? Let's keep going. So RSTU is a parallelogram. We're going to find the missing measures. UT. UT is this bottom side, so I'm going to look across, and hopefully I have the opposite side. I do. It's supposed to be the same, so I'm going to say it's also 27. ST is right here. I'm going to look across. Hopefully I have the one I need, and I do. It's also going to be 18. VS. VS is a piece of the diagonal. So to do this problem, I need either the whole diagonal or the other half of it. And they told me that UV is the 7. And theorem 6.3 says that UV is supposed to be the same length as VS. So if this half is 7, the other half is 7. Then finally I want VT. VT. They didn't tell me the other half, but notice at the bottom they told you that the whole length from R to T is 30. Well, we know that RV and VT are supposed to be the same length. So whatever it is, it's going to take 2 of them to make the 30. So I can simply divide 30 by 2, which is 15. Hope that makes sense how I got that. That's why on the front I included that doubling one piece of the diagonal equals the whole. Okay, I hope that makes sense. All right, let's see what I had left. Okay, so now we're going to do a little bit of algebra using these properties. Okay, so I've got 2 sides marked. One is 11x plus 1, the other one's 19x minus 31. And from theorem 6.1, that tells me that opposite sides are congruent. So what I'm going to do is I know they're the same length. And so I'm going to set those expressions equal to each other. And now we have to solve. Variables on both sides, I'm going to move the smaller one. So 1 equals 8x minus 31. We're going to add 31. So 32 equals 8x. Now I'm going to divide the 8. And I get x to be 4. There we go. Easy peasy. All right. They tell me what NS and SQ are. So what I'd like to do is I'd like to label that in my picture. So 2x plus 7 is NS. SQ is 5x minus 23. So notice what they want me to find. They want me to find NQ. Well, if I follow those letters, that's the whole diagonal. Okay, I want that whole length. But I know both pieces. Well, theorem 6.3 says that the diagonals of a perpendicular, the diagonals of a parallelogram bisect each other. So I know that this piece and this piece are supposed to be the same length. So I am going to set those equal to each other. We're going to solve it. Move the smaller x to the other side. 7 equals 3x minus 23. We're going to add 23. Then we'll divide 3, divide 3. I get x to be 10. Now, what I have to do is I have to plug this 10 back into these expressions. So I'm going to say that NS equals 2 times 10 plus 7. That's going to give me 27. All right. And then SQ is going to be 5 times the 10 minus 23. That will also give me 27. Now we know that this 27 plus the 27 is supposed to give us what we need. So add 27 and 27, you're going to get 54. There we go. Add those two together. All right, two more. We're going to solve for x and then plug it back in to find the measures. So notice we have opposite angles marked, and we know that opposite angles are congruent. So what I'm going to do is set those equal to each other. 6x minus 15 equals 4x plus 11. Move the smaller x. Add this 15. It gives me 26. Divide 2. I get x to be 13. All right, now what I can do is I'm going to take my 13 and plug it back in for all these expressions. So angle A is the 6x minus 15, so 6 times 13 minus 15. You type that in a calculator, you should get 63 degrees. Angle B is 4 times x plus 11. You type that in, you also get 63 degrees. All right. Now, I still have angles, but they're on the same side of the parallelogram now. We know that these are supposed to be supplementary, which means they add up to 180. So I'm going to add them up. 3x plus 5 plus 8x minus 12. Set it equal to 180. I need to combine like terms over here. 3x and 8x gives me 11x. 5 minus 12 is minus 7. I'm going to add my 7. 11x equals 187. Divide 11. So we should get x to be 17. And we're going to plug it in. So P is the 3x plus 5, so 3 times 17 plus 5. When you figure that out, it's going to be 56 degrees. And then plug it into Q. So 8 times 17 minus 12. You figure that out, it's going to be 124 degrees. All right, that's all I have on properties of parallelograms. So the whole idea here, guys, you must know these theorems. You must know that opposite sides are congruent, opposite angles are congruent, the same sides are supplementary, the diagonals bisect each other. You have to know this. And then you use that fact to solve these problems. Okay? So that's all there is for the video lesson. This will be posted alongside the homework assignment um, for your viewing. Please make sure you watch this video, and if you have any questions at all, you need to ask me either in person for those in-person students or through a virtual message like Remind or Google Classroom for you virtual kids. All right? That is all.